Okay, in this video we're going to be looking at total probability and Bayes theorem. Okay, total probability. Given n mutually exclusive events B1, B2, Bn, whose probability is summed to unity. Remember, I explained what mutually exclusive event is in the previous video. These are events that cannot take place at the same time. Then, given any other probability A, any event A, the probability of A is equal to the probability of B1 times the probability of A given B1 plus the probability of B2 times the probability of A given B2 plus you keep going until, probability of Bn times probability of A given Bn. Okay? So this is a conditional probability, but conditional probability that has to do with mutually exclusive events. Now above here are the proof. We can have just an event A. Event A can also be written as A intersection universal set. Universal set in this case is sample space. Okay, so you can see that we represent universal set with the whole of this B1, B2, B3, or Bn. Remember that these all are mutually exclusive events. Now, if we apply our distributive rule, the whole of this is the same thing as A intersection B1, union A intersection B2, union A intersection B3, like that. You keep going, and there we derive this formula. Remember the past video, A intersection B1 is the same thing as probability of B1 times probability of A given B1, and so on and so forth. So we use total probability for any in cases where we have events that have something in common, more than one event, mutually exclusive event that has something in common. Let's see an example here. Example, I have 3 bags that each contain 100 marbles. So there are 3 bags now, each contain 100 marbles. Bag 1 has 75 red, 25 blue marbles. Bag 2 has 60 red, 40 blue marbles. Bag 3 has 45 red, 55 marbles. I choose one of the bags at random and then pick a marble from the chosen bag. Also at random, what is the probability that the chosen marble is red? Okay, how do I know this is probability? I have 3 bags here, and I'm looking for the probability of picking red. And we have red in bag 1, we have red in bag 2, we have red also in bag 3. Okay, so if, let's say, let A be the event. Let's say A is the event of picking red. Event of picking red. Okay, that is to say that PA is the probability of picking red. PA is probability of picking red. And then let's say the probability of B1 is the probability of picking from bag 1. And if you notice, the probability of picking bag 1, bag 2, bag 3, each of them contains 100 marbles. So they have the same number. They all have the same probability. That will be 100 divided by 300. So the probability of picking from bag 1 is 100 over 300. The probability of picking from bag 2 is the same thing, 100 over 300. Of course, that is 1 over 3. This is 1 over 3. And the same thing with the probability of picking from bag 3. It is also 100 over 300, which is equal to 1 over 3. Each of them have the same chance of picking marble. 1 over 3, 1 over 3, 1 over 3. Okay? Now, but the probability of picking red from bag 1, that means the probability of picking a red from bag 1, okay? Given that bag 1 is equal to, now in bag 1 has 75 red but 25 blue balls, that will be 75 over 100. And 75 over 100 is going to give us 3 over 4. The probability of picking a red from bag 2, the probability of picking a red from bag 2 is 60 over 100. Bag 2 has 60 red, so 60 all over 100 and that is going to give us 3 over 5. Now the probability of picking a red from back train, is going to give us 45 over 100, 45 over 100, and that is going to give us 9 over 20. Okay, so this is how we represent it. This is picking red from bag 1. This is picking red from bag 2. That's given that. Remember, this is a conditional probability. And this is picking red from bag 3. So at this point here, we can use our total probability. The probability of picking red, because red is common to both bag 1, bag 2, and bag 3. We use total probability. It is now probability of picking from bag 1 times probability of picking red from bag 1 plus probability of picking from bag 2 times probability of picking red from bag 2 plus probability of picking from bag 3 times probability of picking red from bag 3. And that is going to be equal to probability of, this is 1 over 3 times, this is 3 over 4, plus for this, for bag 2, is also 1 over 3 times, this is 3 over 5, then plus for bag 3 is 1 over 3, then times 9 over 20, okay? So this is going to give us, this is 1 over 4, plus this is 1 over 5, plus this is 3 over 20. The LCM here is 20, so we can find the LCM, which is 20. 4 divided 20 is 5, 5 times 1 is 5, plus 5 divided 20 is 4, 4 times 1 is 4, then plus 20 divided 20 is 1, 1 times 3 is 3. So we're going to get 5 plus 4, which is 9, 9 plus 3, which is 12. Over 20, okay? I think 4 can go, that will give us 3 over 5. So the answer to that question is 3 over 5. Okay, we see the second example here. 3 machines, M1, M2, M3, manufacture 30%, 40%, and 30% respectively of the total output of certain items. Of them, 4%, 3%, and 2% respectively are defective. Of them, so that's conditional, are defective. What is the probability that the item is defective? Okay, we can see first of all that the probability of picking from M1 is 30 over 100, which is 3 over 10. The probability of picking from M2 is 40 over 100, which is 2 over 5. And the probability of picking from M3 is 30 over 10, which is 3 over 10. So they actually mean the probability that machine M1 produced is 3 over 10. Remember, we have 3 machines here, and these are each their probabilities. Now, out of these 3 machines, some of the ones they prepared or some of the things they produce are defective. Like in machine M1, we have 4% that are defective. So the probability of picking a defective, I'm using A now for defective, given that it is M1, is 4 over 100. And 4 over 100 here means 1 over 25. And the probability of picking a defective, that is a defective in M2, is 3 over 100. And the probability that it is defective in M3 is 2 over 100. 2 over 100 means 1 over 50. You see? So you see, out of M1, M2, M3, you can see that something is common between the 3 of them, which is what is defective. Some are defective in M1, from M1, some are defective from M2, some are defective from M3. So if I'm to find the probability now that the item is defective, an item is defective, what would that be? It's going to give us probability of M1 times probability of A given M1 plus the probability of M2 times the probability of A given M2 plus the probability of M3 times the probability of A given M3. Okay, this is going to be equal to 3 over 10 times 1 over 25 plus this is going to be 2 over 5 times 3 over 100 and plus this is going to be 3 over 10 times 1 over 50. Okay, this is 3 over 250 plus this is let me say this is 6 over 500 plus this is 3 over 500. The LCM here is 500. Okay, this is 500. Now 250 and 500 is 2. 2 times 3 is 6 plus 500 and 500 is 1. 1 times 6 6 plus this is times 3 3. So that's going to give us 12 plus 3, which is 15 over 500. Something is common, which is 5. So the answer to this is 3 over 100. Okay. So the next question here. An automated blood pressure machine is being tested. Members of the public, about 20% of whom have high blood pressure, that's hypertension, try it out, and then seen by the doctor. She finds out that 80% of those with hypertension and 10% of those with normal blood pressure have been diagnosed as hypertensive by the machine. Did you see that? So the first question we asked to calculate the probability of a correct positive diagnosis. Then the second question we asked to calculate the probability of a correct negative diagnosis. Now, what do we understand by this? In that very community, 20% of them are hypertensive. So we can say that probability of those that are hypertensive, let me call that B1, is equal to 20%, 20 over 100, which is 1 over 5. That means that probability of B2, those that are not hypertensive, is 1 minus 1 over 5, which is 4 over 5. Okay? So the fraction of those that are hypertensive is 1 over 5, while the fraction of those that are not hypertensive is 4 over 5. Now, both of them went for tests. Both groups of people went for a test. And one of them tested the probability of having a correct diagnosis given B1, probability of A given B1, is equal to, the question says, 80% of those with hypertension were diagnosed positive. So the probability that you are diagnosed positive, given that you are hypertensive, is 80%. So 80 over 100, which is 4 over 5. Then the probability that you are diagnosed positive, given that you are not hypertensive, that they are not hypertensive, in the question is 10%. So 10 over 100. And 10 over 100 is simply 1 over 10. Okay? So the question here is, we are asked to find the probability of a correct positive diagnosis, that means probability of A. That's what we're asked to find, probability of A. And probability of A is equal to probability of B1 times probability of B1 given A plus probability of B2 times probability of B2 given A. Okay, so that is it for the probability. Oh, sorry, this is A given B1. And this is A given B2. Okay, so this is equal to The probability of B1 is 1 over 5 times the probability of A given B1 is 4 over 5 plus the probability of B2 is 4 over 5 times the probability of A given B2 is 1 over 10. Okay, so that is going to give us 4 over 25 plus 4 over 50, which is the same thing as 8 plus 4 over 50, which is 12 over 50. 12 over 50 is 6 over 25. Okay, I would like to reiterate here that the probability of giving a correct positive diagnosis means that what's the probability that it is correct? What's the probability that the diagnosis is correct? Okay, and the probability of a correct diagnosis is A. The probability that